Okay. Good morning. Good morning, everyone. My name is Paddy, and today I will present my report to satellite views of cross-strait sediment transport in the Taiwan Strait driven by Typhoon Murak. And Typhoon Murak was a powerful storm that hit Taiwan on August 6, 2009. It caused powerful extreme rainfall and lead to significant sediment transport in the Taiwan Strait. And this a green dot is moderate typhoon. Yeah. And Taiwan Strait is a crucial channel between China and Taiwan. And this study is based on sea surface temperature (SST) and total suspended solid (TSM). And the Taiwan Strait is a key waterway between China and Taiwan, influenced by typhoons, ocean currents, and monsoons. And the red route list is the Typhoon Murak trajectory, and the black arrow like this is Taiwan warm current, and this white line is cross strait section, the relevant area for the analyzing sediment transport. And the Taiwan warm current flows northward and acts a barrier to sediment movement. However, during typhoons, wind stress and aqueous transport can disrupt this pattern, allowing sediment to be transported across the strait. And to analyze the impact of the typhoon, we use satellite remote sensing data from MODIS and ACOA to measure SST and TSM. And we divided the study period into 3 phases. Number 1 is before the typhoon, August 1 to 7. Number 2 is during the typhoon, August 8 to August 14. Number 3 is after the typhoon, August 15 to August 21. And by comparing SST and TSM before, during, and after the typhoon, we can understand how sediment was transported across the Taiwan Strait. And this one is before the typhoon, and during the typhoon, and after the typhoon. Okay. Now we can see SST drop maybe 2 to 4 degrees during the typhoon, and TSM increased significantly. And after the typhoon, SST started to recover, but still lower than pre-typhoon levels. And TSM dropped, but still higher than before the typhoon. And before the typhoon, summer monsoon dominates and wind strength is small. But when typhoon come, the wind field direction change over time because of the typhoon. And after the typhoon, wind strength returns to near normal values. And during the period affected by typhoon is August 8th to August 14th. And the Ekman transport before and after a typhoon was low transport rate, but during typhoon, during the typhoon, Ekman transport increased significantly. Yeah, up to maybe before is 小于10 m 平方 s, but during typhoon up to 200. Yeah. And when typhoon enter the Taiwan Strait, it generated eastward transport, and it brings sediments along the coast of China to the center of the strait. But when the typhoon leaves the Taiwan Strait, it produces westward transport. Here is during the typhoon, the direction is changed. Yeah, yeah, south and north. Yeah, and to to understand impact of different typhoons, we compared it with other typhoons from 2004 to 2015. And the first one is passing through the northern part of the strait. The number two is typhoons that cross the strait directly. And number three is typhoon passing through the southern part of the strait. Okay, and these results show typhoon passing through the northern and southern strait, and typhoon that cross the strait directly. And we see typhoon that directly cross the strait and passing the northern strait cause the largest sediment transport. But when typhoon cross the now southern strait, it cause smallest impact, because the southern sea is mainly sandy sediment, so it cause smaller impact. And conclusion, typhoons will promote sediment transport across the strait through wind strait and Ekman transport. Different typhoon and entry routes have different effects on sediment transport. And after the typhoon, TSM increased significantly, especially in the center of the strait, while SST gradually recovered, but still lower than the pre-typhoon level. Okay, thank you.
Can you explain again the plus? And I'm wondering what is the dots means.
Dots.
The black dots.
The black dots.
Yeah.
Is different typhoon come to Taiwan route. Yeah.
So okay.
Yeah, it's different color.
Okay. Thank you.
Can you talk about this feature again?
When typhoon come, Ekman transport will increase many, because before and after the typhoon is very small, but when typhoon come, it increase up to 200, almost 20 times.
Okay,
Yeah.
okay, thank you.
So why most of the typhoon during that time is in the north of Taiwan, but there are not any typhoon?
Impact is smaller because the southern strait, they mainly sandy sediment, and the sediment are mainly transported to South China Sea. So they instead of staying in the center of the strait, so they transport in the South Sea and not stay in the strait. Thank you.
Your title is wind straits and Ekman transport. So, what's the relationship between wind strait and Ekman transport during the typhoon?
Good question.我回去看一下。
Okay, thank you.
What is the importance of the transport of the sediment during the typhoon in Taiwan Strait?
Normally, they transport typically, but typhoon and
You know that this paper was assigned by me, so he was probably not so interested in it, maybe, but it's okay. I think he has done some certain amount of work, and it can be improved. First of all, I think regarding Rotalia's question, what is the general importance of this topic? I think that's something I can tell you. That's fine. This is because you have to consider that sediment transport and burial is the ultimate mechanism of carbon burial on Earth. So if we want to say that a carbon atom is removed from the carbon cycle, the only pathway is carbon burial. It's like you dump garbage away. And the main mechanism in Taiwan for sediment transport is typhoon. For 99% of the time, Taiwan transport very little sediment, except the only 1% is typhoon. So most of the sediment transport takes place during typhoon. That's the reason why we want to study this. I hope that next time, anyway, you will see the video footage. Please add this part into your talk to make it more interesting. You need to tell them the importance of your study. I wonder, did you read your objective? Did you? Sometimes I feel that the line you read doesn't match your text very well. At some point, I'm not sure, did you ever tell them clearly the objective? So when you have a slide where you show your objective, you need to read it very clearly. I think this is a little bit too much, okay? So please condense it to a certain shorter sentence and color some keywords, because I don't read this kind of text. It's too much text. And starting from slides 4 to all the results figure, I think you can make it larger, like this large. Make it really large. It will be easier for me to see. And also, when you were introducing your results, like here, you need to keep in mind that you need to introduce it. You don't need to introduce this is longitude, this is latitude, no. But you need to explain this is TSM. And the red, the warm color means what? Higher concentration. SST, warm color, means higher temperature. You need to say that. You need to introduce it. And here you were like saying before typhoon, which date to which date. But the better way is when you say before typhoon, you can point to the figure already. Before typhoon, typhoon period, after typhoon, you point to them. And the same here, because when you were presenting your results, the text and the figure were separated. You always read your text first, and then I'm not sure if you ever guide us to your data, but the data should be more important. So the correct order is you tell us with a really large figure, okay, this is SST before typhoon, after, and it's actually a difference, okay? It's pre versus typhoon active period. So it's the difference between two periods. You need to explain that. And this is also difference, right? And this is also difference. So you need to say that. You tell us what are these figures, and then you use some guideline. You can check like Ariel's presentation or Carl's presentation. They use a lot of guideline to say, look at this, look at this, look at this. We know what to look at. Otherwise, it's not clear. Like this is the thing we should look at, right? Then you use a circle to point this out. That's the thing we should look at. Use guidelines. Regarding wind stress and Ekman transport, which you was not able to answer, I hope that next time you can have one, because your talk was too short. Next time you should add one slide explaining what is the relationship between wind stress and Ekman transport. And if you don't know it, you have many good classmates who are interested in physical oceanography. You can ask them in Chinese. Okay?
Okay.
Good. And use image to explain this. You were unable to read this. I hope next time you will be able to do that. Less than 10 square meter per second. Anyway, you can check the video later. And also, you didn't introduce the figure at all. Okay, this kind of figure is actually not that easy to read, so you need to introduce it and make it really large, please. Really large. Here, you were talking about 3 different kinds of paths. And next slide, you talk about their impact on sediment transport. I hope that next time when you introduce the first type, you can show, I don't know which 3 because the figure was too small. Maybe the 3 is the northern path? Maybe? I don't know. You show the corresponding TSM data when you talk about the first one, where you have this animation, right? Then you show the sediment, the TSM data. Then next, then the middle part, then the southern path. I think the third point was not supported, really well supported. I think you should say, regarding the third conclusion, you should say something related to this one, where when you have different paths, the influence on sediment transport is different. And the final thing is, I think your English is good enough. So I think next time you should look at them. Yeah, I think you can do that. Good. Thank you, Patty.